The question is a metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes angle of 30 degrees with the horizontal. The rod is not allowed to slide down by flowing a current through it with a magnetic field of induction 0.25 T is acting on it in the vertical direction. The current flowing in the rod to keep it stationary is willing to find the current value of current which we needed to keep the rod in stationary position. So in this question we know that magnetic field of induction, that is B, is equal to 0.250 and the angle formed is 30 degrees with the horizontal. Mass per length is also given 0.5 kg per meter. Now, according to the formula, F is equal to BIL. Force is equal to B magnetic induction into current into length. We'll use this formula to find the value of current. So and in this, according to this question, F sin 30 degrees is equal to mg sin F cos 30 degree will be equal to mg sin 30 degree. We will show that in the next slide how it is going to be there. So when we'll equate that and try to solve that equation, so the value of y will come out using this formula. Now let's see how it is going to be. F cos 30 degrees will be equal to mg sin 30 degree. Now as 30 degrees is formed between the horizontal and the force acting upon it, so F cos 30 degree will be equal to mg sin 30 degree as shown in this diagram. And when we substitute the values that were given in the question with F cos 30 is equal to mg sin 30, that will give us BIL sin 30, cos 30 will be equal to mg sin 30, and when we equate this equation, I will come out with the formula that we derived in the previous slide. And when we substitute the values, it will be like 0.5 into 9.8 divided by 0.25 into 866 whole multiplied by half, and that will give us the value of I to be 11.32 ampere. That is the first option.